Do you guys? How many of you guys have antenna analyzers? You guys do all this kind of stuff, right? I know. Rick's got one. There it is. There's probably the exact one I got.
MFJ 269.
Mine's a 269 as well with the UHF button. And I love this thing. It's my favorite piece of equipment. And so what we're going to do is I'm actually going to hook up different antennas and we're going to sweep them and see where they come up. I was kind of hoping to have more people in tonight because there's a lot I can still learn on this. And so I was hoping if you guys see me doing something or you have something to add, please don't be shy. As you guys know, I consider myself kind of a newbie. And so criticism doesn't bother me. Okay, here we go. This first antenna that I put on here, this is a Bofang antenna. It's off of one of their waterproof radios. It's one of their nicer radios. It's about a $50 radio. It's the UV9R, I think it is. UV9R. It's their waterproof model radio. It's a really cool little antenna. It doesn't look like the other Bofang antennas. Anyway, I put this on here and I set my tuner for VHF and I started sweeping. And what I noticed right off is that it's actually right in the middle of the band. I mean, 1.4, 1.4, that's the best frequency. And that's pretty much where you want to be. I mean, 144 to 147. So that's really not bad. That's really not too bad. So we're bottoming out about 1.4. That's about as good as we're going to get. And the entire ham band is in tolerance. What do you guys consider tolerance on VHF? SWR 2 or 3?
1.5.
Yeah.
Man after my own heart. I'm picky on SWR, but everybody else is like, 3, go. I'm like, no, not with my radio. Okay, and I'm probably overprotective because I don't have a lot of money, and I tend to be overprotective with my equipment. But anyway, as you can see here, as we go down, the numbers go way up. Let's take a quick peek since we got it hooked up here. Now I want to show you guys something. This is supposed to be a dual band antenna. As you guys know, it's a VHF antenna and the UHF is harmonically achieved, basically. And I want to show you guys something. When you get up into the 440s where we're at, notice what the SWR is. It's horrible.
Yeah. All
the way through the entire amateur radio swath of the UHF band. It's out of tolerance.
Okay, but one of the things that you've got going for it is you're holding it out there on that stick, and it's out there by itself. What happens when you emulate by putting your face next to it, so that it looks like you're holding a radio with the antenna right there next to your head?
You're actually beating me to the punch here. I simulate that by holding on to the metal part of the antenna here. That kind of simulates me holding on to it, and you can see it does greatly bring it down.
Almost 2 to 1.
We're within tolerance now, or close. So, and that's kind of what I was wanting to demonstrate here, was that when you test these HD antennas, especially, they're not grounded. There's no ground plane. And when you hold the portable radio, you become the ground plane. I played with tiger tails for a while. Have you guys ever done tiger tails? They call them different things, but you just make a little U-clamp that goes underneath your antenna when you screw it on your portable, and you make you a couple of aerials, 1 or 2 or 3 aerials that come off on your portable. And if you make them the same length as your antenna, I've had pretty good luck with it. I built one of those for a while and was using it to get on some different nets and stuff with a Bofang. Because the biggest drawback to these is you are the ground plane for these antennas. But as you can see, if you ground it, or I could hold my face up next to it and put my hand around the tuner and probably get about the same result. You're absolutely right. That's what we get with these. Now, we'll go ahead and I'm going to throw another one in here. That's this is the stock Baofeng antenna. This is the one that comes with the UV5R. It's probably the most made antenna ever in the history of human beings. And I just want to show you guys what that kind of looks like on the meter. Okay, now I'm going to touch it to kind of simulate the ground. And we see that, again, we're just barely in tolerance as we go up through the 440s. We're in the 2.3, 2.4. And of course, it gets a lot worse if I'm not touching it. Again, this antenna it's a VHF antenna, and they've literally just they're using the harmonics basically just to achieve what they're trying to do. All right, here we look at the VHF sweep. Not very good at all. Not very good at all. It gets within tolerance, but notice where we're at. Everything over 145.4 is a 3. And then we get up here, we're getting up a little higher here. It gets better. But still, 1.8 is the best we can do at 150 megahertz, which is out of our SWAT. So, why does this antenna seem to work pretty good on these Baofengs? Well, I'm going to tell you guys something. I did an antenna test a while back, and I tested the little antennas versus the big antennas. And you want to know what I found? The performance of the stock antenna that came on that radio tends to do about the best you're going to get. I bought these larger antennas, these Nagoyas, and the I'm trying to think of the name of the other one. There's several of them here. This one's actually made by TYT. This one is a Nagoya, but I think it's fake. These antennas, although they're great, they got this big old tall piece on it, and you'd think that's really good. What you find out is that the performance of these is no better than the smaller antennas. I don't really know why that is, but I actually did an entire test on these, and I'm going to try to pull that up here in a few minutes. Okay, I just put on a large antenna now, and again, I'm going to hold on to this to ground it, and we're going to run back through the VHF again. And look at that. It's literally just crap. It's like it's not even hooked up, but it is. Look at that. I got this with my good radio from TYT, my really good radio that I really, really like. Here's another one that came with another radio I bought from TYT, and I even find performance differences in these. But again, we throw this on here, ground. And again, I can put it up next to my face. I don't think you're really going to, you can see there, it does get a little lower when I'm right up next to it. So we're going to give it a little bit. All right. Look at that, guys. Again, it doesn't do worth the crap. So your SWR is no better with the taller antenna. Let's check the UHF. Usually the larger the antenna, it doesn't do as well on UHF. Look at this. It's so far, let me hold on to it. Maybe that'll help. It's so far out of SWR, it's not giving me an SWR. It tries to resonate about 420.
Yeah.
I know some potheads that resonate about 420. Anyway, all right. So what you're basically looking at, that antenna has a worse SWR than the cheapie that came with the radio. That kind of sucks. All right. This is that Nagoya. I'm going to throw it on there next. I think this is a knockoff. Nagoya antennas are the #1 faked antenna online. Even on Amazon, you'll end up getting a fake one. Okay, so here we go. There's my Nagoya. It says it's a Nagoya NA771, 144 and 430 megahertz. So let's go to 144. Nothing. I'm moving this all around and make sure, you know, okay. If I move it around, I can just almost get something here. Look at that. It's terrible. That's why I said I think this is a fake. I bought this thing and brought it home, put it on my radio, and I'm like, that's terrible. On VHF, it's a little better. It's within some people's tolerance at this point. But look at this. It climbs up. By the time you get down to 444, 445, you're over 3. What's going on? What the hell's going on? I don't know.
Ian, that button on the top of that thing, the UHF button, when
Yeah.
do you push that? Do you know? I don't understand that. I've got that too.
Well, like right now, you set it on VHF like I have it right now, all the way to the left. And then when you hit the UHF button, it turns it into UHF mode. Now, your 2 gauges down here don't work anymore in UHF mode. It's only up here. And you also don't get the rest of the readings, but you do get the frequency and the SWR. That's all it'll give you in UHF mode.
Yeah.
But see, there you go. There's your frequency and SWR.
I've never tried that before.
Yep, that's all you do. And then when you're done with it, you just turn that switch back off, and it restarts and goes back into VHF mode again.
Yeah.
Yeah. Yeah, UHF is the pickiest one out there, so you got to have that. This is pretty cool. I actually have the camera mounted to this thing, so I can actually move it around, and the camera is mounted to the device, so it doesn't move. I thought that was kind of cool. It's a little blurry, but you guys can read the numbers. That's really all that matters. Okay. I'm going to try a couple of other things here. You ever wonder when you buy a 220 radio and you get the thing and it comes with 2 different antennas and you're like, hey, I got this one antenna like this one and it's got the yellow in it. See that?
Yeah.
It's the 220 antenna, right? It's the one for 220. So you got to remember to change it out on your radio when you go to 220. So I wanted to show you guys what happens when you sweep one of these 220 antennas on the other bands. Look at that.
Yeah, suck.
And you can see as I get closer to 220, it's coming down. Now, I don't actually, this thing doesn't do the 220 band, so I have no way of doing the actual band. But I just want to show you, when you forget to change the antenna on your little 220 Bofang, your tri-bander, if you forget to change the frequency, this is what you're transmitting with right here, 22 megahertz, you know.
You may be able to get down the street with that, but that's about it.
Yep.
Tie a post-it to the radio, and then you can talk as far as you can throw the radio.
That's about right.
The post-it might come off.
And notice on the 440 band, you're not going to get anything. You're not going to get anything. So the moral to the story here, guys, is those 220 antennas are worthless for anything but 220. I wanted to put that out there. One final antenna on this kind of antenna that I want to show you. Actually, I got 2 more. Let me do this one. This one is a Comet. I have found Comet to be one of the better manufacturers. I've got 2 Comet antennas, and they're 2 of the better antennas I have. So I'm going to put this little thin, wispy Comet antenna on here. And I'm going to go ahead and ground it with my finger because we've been doing that with all of them. So that's kind of how we're doing the test. And let's see where we're at on 440. It's worthless. And it's even worse when I let go of it. So yeah, it's worthless in 440. Let's take a look at it in VHF. I bet you if I cut it in half, it'll work a lot better on 440. Look where my SWR is on this. It's way down here at 143. See that?
Yeah.
You get up to where we're at, and look how quick. This thing has no, when you have a coily antenna, it gets a little wider bandwidth than when you have a little wispy like this. Look at that, how quick it goes up like that. That's crazy. Okay, and then the last one I want to show you, I'll take off from here. This last one is the antenna that came on my $70 TYT. And this one's a much better antenna. And you can see here, look at the difference. So I'm kind of SWR1 right around where the repeaters are. And then I get to 2, but still all through the ham band, I'm pretty much at 1 or 2. So that's not so bad. Let's check the UHF side. Well, at least it's on the chart. But again, not so good. It's kind of amazing, isn't it, that they sell these things and they really just don't they don't perform. And I'm going to tell you the reason for that is like threefold. Number one, it's not going to perform like a big old huge great antenna. But I think the other things you got to remember with these is the radio is paired with the antenna. When I leave the antenna that came on the radio, it seems to have the best performance. When I start mixing and matching antennas and trying different aftermarket antennas, I never have as good a result as when I have the original antenna for that particular radio. And that's kind of been where I'm at with that. So any comments, questions, or discussion on portable radio antennas? All right. You guys are talkative tonight. All right. So that's where we're at with that. Now, as far as mobile antennas go, I don't really have a mobile antenna we can actually test here, but they test like everything else. You're going to find mobile antennas. If they're of a higher quality antenna, like I got this like Ringo kind of thing, this big tall Ringo antenna on there, and it gets an SWR1 all the way through the entire ham portion of the VHF band. It's great. It's just a wonderful antenna. You buy these cheap $15 antennas from Amazon. You get $15 magnet mount antenna. You're going to get some performance out of it, but it's not going to have a real wide bandwidth on it, and it's not going to give you near the performance you get out of, say, a $60 or $80 antenna. All right, I want to start with. We're going to start with my tower. This one's actually going to be coming down here probably next couple days. This goes up to my dual 7-element VHF, and the connections are all in the weather up there, and I've got some problems, and it needs to come down and get serviced anyway. But let's just see where we're at. When I put it up at SWR, not really nice. But let's see where we're at. Let me make sure I'm out of UHF. All right. Now, like I said, this is a dual, 2 different 7-element Yagis that are up on my tower on a 50-foot piece of coax. And it's at about 30 feet shooting to the northwest. And you can see here that it SWRs out pretty nice. A little high at the lower end of our swath, but still well within acceptable range. And then, of course, it gets pretty low, or get down to 4. This got a lot better when I first put it up. It's been up there over a year, and the connections have got water in them and stuff. So I expect to get this back to a really good performance. I'm going to be reinstalling these two a little bit lower on a side tower, and they're going to be fixed facing towards the NI4CE system, which is the big Tampa Bay area system. Okay. Now, what's cool about this is my antenna up there has always done really good on UHF. Even though it's cut for 2 meter, obviously, But look at this. It does. It's all acceptable. Look at that.
Not bad.
Oh, look at that.
Mhm.
I mean, that's just nice. I don't care who you are. So, I mean, you can see I'm doing pretty good with it. I built this out of PVC pipe about 14, 15 months ago, and it's been taken down and put back up 3 times, and it's all bent up. But I get good performance with it. Look at that. Oh man, that's not bad at all. All right. But yeah, that's my my dual 7-element beams that I built myself. The next one I'm going to test, show you guys the sweep on. Um, this is my homemade 3-element 2-meter beam. This is the one I use to talk to the 685. When I have this out here on a side antenna piece that I had about a 20-foot piece left over, a tower, and I just have it stuck over here with a bunch of Yagis stuck on it, and it's shooting towards the 685. I did that so that I literally can hook this up to a Belfang and I can talk on the 685 with a 1 water. So we'll see how it tests out. It's been up there in the weather for about a year, and it's like I said, it's a homemade Yagi that I made with 3. I actually took aerials off of 3 old antennas that Joe gave me. I took the aerials off of 4 antennas, and I cut them all up and made the two driven elements, the one front element, and the reflector element in the back is actually 2 antennas, and they're bonded together, and that gives them the link they need to be the reflector, and that's what we got here. And look at this, we're talking about all within acceptable range. Look at that, 444, 1.1. I have great luck with my homemade antennas, and I'm going to tell you why. They're non-conductive booms, non-conductive mass, non-conductive beam. The only thing conductive up there is the driven elements, or the elements. And I think that makes a big difference. It gives you a better SWR. The entire ham band is 1.5 or less. And look at that, I get back to 1 again up here. So really good SWR in that. Let's go down and check the VHF side. It's actually cut for VHF. And look at that. Ah, so sweet. It goes up pretty quick though. Notice how quick it goes up, but it's still all within the acceptable range. Oh, and we go back down again. I love Yagis. So definitely all within the acceptable parameters there. And like I said, I can make the 685 with this with 1 watt. It's about 8 miles away. And it's up only about 17 feet, 16 feet, something like that. So real happy with that. That's good performance. So that one can easily be used for UHF or VHF, and then I can go out there and manually spin it around to wherever I need it. I'll take a look at something interesting. This is my 6-meter beam. This is my 6-meter beam. Okay, let's see what we got here. Look at that. It's got a usable SWR at 152 megahertz. Now, the pattern would be all over God and country, and it probably wouldn't do you any good. But that's interesting, isn't it? That I'm getting a usable SWR through part of there. But I can take my tuner and switch it to the 27 to 70 band and get it down in the 50 range right there. Look at that. Boom. What is FT8 is 50.074, I think it is. Something like that. Get that. Let's see what that is. Hold on. 53. And the other one is 5313. 5313. So that's the one I'm using pretty much, 5313, something like that. So it's a 1.3 SWR. That's really not bad. So I use this obviously without a tuner on 50, and it works great. So that's my 6-meter beam. And then any questions or comments, you guys just spit them out. There's only not that many of us in here, so. All right, the next one. This is my rear Ringo Ranger. I have two of them. I have one in the front, one in the back. This one is up on a 30-foot pole, about 27 foot, and then it's about an 11-foot antenna, so I'm almost 40 foot at the top. This is my second best performer, but I'm going to show you, I got two identical antennas. This one does not have the proper ground plane on it. The other one does. And you can see here, still does pretty good. Look at that, not bad. It bottoms out at 1.2 at 145. That's about where you want it to bottom out, wouldn't you think? 145, 144. Look at that. Really not bad. This is a Ringo Ranger. It's way up on a pole, and I got my other Ringo Ranger here. Let's get that over here. I don't know if I can make this one reach. I'm gonna have to lift this up a little bit here. Okay, this one is my other Ringo, the one out in the front. Look at this. Because it has the proper ground plane, look at the difference. We start at 1.2, we immediately go up to 1.1, and then that's it. It stays at 1.1 all the way through to there. Look at that, and it resonates again at 149. So it does really good. This is my best performing VHF antenna right here. This is the one I use on the simplex net. When you guys hear me on the simplex net, this is the one I'm using. Let's check the UHF side of it. Look at that. It peaks at 152, but then it has another peak at 149 or 449, and then so it's got multiples here. Look at that. That's really good. That's a really good SWR right there. So I have great luck with these Ringos. They seem to last a long time out in the weather too. So very happy with that. And then the last thing I want to show you guys, and I do want to mention real quick, I know we're short tonight. I know about 5 people that have stuff going on tonight. And I myself have got very bad back pain tonight. So I planned on not going real late anyway. So, and I'm looking at faces. You guys all look about as tired as I am out there. So let's go. This one here, just for giggles. This is my long wire.
Oh, okay. Let's see what that does.
And we're going to go down, and I'm going to start at 1.8 to 4 megahertz. Go way down. Put this. Oh, I can't put it right here. Okay, here we go. Yeah, see, that don't really. and it does not like 160. I have a real hard time getting any kind of SWR on 160. Now I get down here around 40, and you can see it's not so bad. My tuner has no problem with 40.
Hmm.
And then, but you can see as I go up, it gets more and more difficult on my tuner. We get up to 28 megahertz or 10 meters, and you can tell my tuner has a long way to go to get that thing in. And then 50, I have a real hard time with 50 on this wire. I've never really been able to use 50 on the wire, which is fine because I don't need 50 on the wire. Look at that. It's like terrible.
What is that? Just a random piece of wire, or is it a certain piece, certain length?
It's a random length dipole wire. It's just two wires that come out of a balun or whatever it is.
Okay.
Sorry, I've some of this is like, but if I wish I could have had my hex up, we could have run a sweep on that. That'd have been cool. But you can see why at 50 my tuner has such a hard time with it. Of course, there would be no performance at all up on the VHF frequencies, even though you can actually find where it resonates a little bit, but you know there would be no performance there anyway. All right. Okay, anything on that? Anything on the tuning stuff? I thought there'd be more discussion on this.
Yeah, my hex beam resonates in various weird places. You know, below 20, about 20.6 megahertz, and then about 21 dot into the 15 meter band, and strange places. Must be
It
some
is very strange how it works, I got to tell you. But anyway, the antenna testing I did, I basically took. I wish I could find that real quick, but I don't know if I'd ever be able to find it because it was like over a year ago. It was the first study I did. Let's see if I can find it real quick. File open. I can hear over on NICE coming in clear tonight, actually. I can actually hear it coming in really clear tonight on my beam. Okay, open. Why is this thing so slow? It's like it's not broadcasting. Okay, here we go. What I did was I basically took all the different antennas that I had at the time, and I went down the street and I screwed each one on the same radio, so that I was using the same radio, the same test. Everything was the same, right down to, so I had everything was it was a scientifically valid test, basically, of all the different antennas to see which antenna seemed to work the best. And what I found surprisingly was that the aftermarket antennas were not always better. A lot of times we think, well, I'm going to buy an antenna that's aftermarket for 30 or 40 bucks and screw it on my radio, and I'm going to get a lot better performance. And it sucks because that isn't what happens. Yeah, I don't know if I'm going to be able to find this or not. I'm going to check for one more thing here. It's been a while since I've done this, but I think it might be my other account. Does anybody have anything else on antennas while I'm looking this up here?
Nope, not really. Yep, I'm live.
Yeah, I got to tell you guys, the MFJ is definitely, in my opinion, the MFJ antenna analyzer is probably the best one as far as the simplicity of it. There's others that will give you a lot more information. Now, whether that's a good thing or not, I don't know. I kind of like this one because it gives me exactly what I need and nothing more. Oh God! Oh, this
Well,
stupid
that
thing.
VNA that you got rid of, if you was to have mastered it, you could get a sweep and you could see the nulls at one time. You don't have to grab the knob and tune from one end to the next.
Right.
Does all that.
You get to see from like
Yeah. No.
143 to
I actually.
148, 149. You get to see where the low spot is, the high spots. And when you were going to do your long wire, if you had a in-fed antenna that was resonant on 3 or 4 bands, you could see all of those resonant spots with one sweep.
Right. Just so you know, I had a nano for about a year, and I used the heck out of it. I was even starting to figure out the whole Smith chart thing. So I'm not down on them at all. In fact, I like them. I just I got this, and I never went and used that one again. So
Well,
anyway,
what you've got is a really nice one, and especially if you're out in the field and doing something, you can see those meters. And with the flashlight, you can see those meters in the dark. That nano VNA outside in the bright sunshine, it's nothing.
yeah. No, I know they're hard to see out there, and this thing you can see no matter how much light there is. All right, guys. Here's the full screen. There we go. This is my antenna test I did, and we'll just get rid of that. But anyway, this was the antenna test I did. I was a member of that club back when I did it. But anyway, what I did was basically I was looking at the SWR and the impedance of each one, and then I practically tested each antenna using a control radio and a distant station. Um, this shows you what I used. I used 2 identical receivers, one with the Yagi facing towards me, and one with the Yagi facing on a 45-degree angle. I kind of did that on purpose to kind of give me 2 separate UV meters on them, so I could kind of see, see what kind of power I was getting. I used this radio, which is that waterproof one I told you about, the UV9R, and I set it on 8 watts. And then of course I used my antenna analyzer. And then what this shows you is each one that I used. A lot of these were the same ones I used tonight. This one here is this one right here. As a matter of fact, same antenna I tested tonight. And you can see here where it tests out. But I want you to see the performance of it. It did okay on the test. At 3 miles away, it was still a 55 and a 50. That's not so bad. See each one. This one is the antenna that came on the radio. Notice pretty much the same numbers. It's the exact same numbers. So you can walk around with this big old double size antenna on there, or you can just keep the one that came on it. You're going to get about the same performance. That's what I found. And if you notice, the SWR is about the same. They're all about, it's about equivalent on SWR. If you guys want, I can always send you a link to this. It looks like I need to do some formatting, but I probably should republish this. Here's another one. This one, man, I gotta fix this format. There we go. This one here is the Belfang standard antenna. It's about the same performance yet again. About the same SWRs. There's a little Comet that I tested. That one I tested earlier. Again, about the same performance. We didn't notice a big performance difference. Hey, here we go. This is that Nagoya that I bought for $22 or whatever. Look at the performance. It's horrible. It actually is horrible. It sucks. And actually doesn't work near as well as just a stock antenna that came on the radio. This is the TYT high gain, and it did actually give me a little bit of gain, but it wasn't a big deal. It really didn't help me that much. Look at this. This was surprising. The Abri Tactical 48-inch folding antenna that I bought. Now, I have no doubt that if you're out in the middle of the woods and you got to get an emergency signal out, I have no doubt that just the length of this thing is going to help you. But that being said, it really didn't have any better performance than the stock antenna according to my testing. Now, this test is by no means conclusive, but what I found was I got about the same performance with this as I did the ones that came on the HDs. So that was basically they all basically had about the same performance, except this Nagoya had dismal performance. Again, I think I got a knockoff. I really do. And this entire test was done on VHF. I find that the stuff that you find on UHF is much different. This is the actual TYT stock antenna, the one you're looking at. It's this one right here. This is the actual stock antenna that came on my TYT. It has the best SWR and the best performance of any of my portable radio antennas. And it came on my $68 UV8000 that I bought from TYT over Amazon for $70, $68, whatever. And that's what I found. So it's kind of interesting to me that that literally you can have one kind of antenna, another kind of antenna, but the one that came on the radio sometimes is the better performer. And I start to there's that mean face again. I start to wonder why that is. Why is it that that of all of them, that the one that came? But I think it's because when they built that radio, they built the antenna to go with that radio, and then they mass produced it. So I think the antenna is designed to work with that radio and maybe even work around its little issues. That's my opinion. What do you guys think?
There's a lot to be said for that, and they may have tweaked and peaked the radio for that. You know, you mass produce the antenna, and then you tweak the radio to match it. So the tuning circuitry that's in there has been optimized for whatever wonky characteristics that antenna had. You changed the antenna, well, you've got a different wonky characteristic. The radio's not happy.
Exactly. So there you go, and that's what I found. I don't know if that's enlightening to anybody, but I suggest doing some testing with your stock antenna and doing some testing with your aftermarket antenna, and see if it's worth carrying that big old long thing around that's knocking everything off. You might. I used to carry. I got my radio right over here somewhere. I used to carry this radio around with this big old long antenna on it. Now I'm back to the stock antenna is what I always have on it because it works just